Hello, welcome back. We are in Chapter 5, Lesson 2, and we're interpreting graphs. I want you to go ahead and try problems 1 and 2 on your own. And so go ahead and press pause. When you get done with those, press play, and we will see you in a bit. Okay. All right, let's see how you did on problem number 1. It states that a ball is tossed into the air. Which graph best shows this? So this graph has time and it has elevation. So this graph, when time begins, this is when time is 0, this states that the ball would already be in the air. It would remain in a constant elevation, and then the ball would increase in elevation a little bit as time persists, and then it would remain at the same elevation. And then the elevation would drop, and then it would just, be at a consistent elevation, kind of hovering in the air, which isn't necessarily the nature of a ball. A ball, you are probably at 0 elevation, it goes up in the air, and then it reaches its maximum height and then goes down. So let's look at here. So here, as time begins, the elevation is at 0. The elevation steadily increases. It kind of hovers in the air for a short amount of time, and then it drops. So I would say that B is the graph that exhibits the pathway of a ball being tossed in the air the most. So if you got that one right, great job. Let's go on to problem 2. This says Sam inline skated 1,000 meters from his home to the park, where he rested on a bench. He then returned home. Sketch a graph to show the distance he inline skated compared to time. Use your graph to find the total distance traveled. So he started at home, and as he started skating, time started. So let's say that he started skating and he went 1,000 meters. Right here, that would be, this represents 1,000 meters. Whoops, 1,000. And then what happens is he rested on the bench for a while. We don't know, but he rested on the bench for a while. Okay, so he didn't get any closer or farther from his house as he was resting on the bench. And then he returned home, so he went back home. I'm just going to extend out that line a little bit. And there we go. And if he traveled 1,000 meters, he rested, then when he went back home, it would also be 1,000 meters. So this would be an example of a graph that would fit this particular situation. It says, use your graph to find the total distance traveled. So here on the graph, it shows that Sam traveled 1,000 meters away from home and then 1,000 meters back to home. And so if we add up those two values, 1,000 plus 1,000, we get that Sam traveled a total of 2,000 meters. So if you got that one right, great job. Okay, let's go on to the next example here. I'm trying to give you quite a few examples with this just because it's important just to get a lot of experience with these types of graphs so you get in scenarios so you get better at interpreting them. So let's look here. How about you go ahead and try these on your own? Problem 1 and problem 2, okay? So go ahead, press pause. When you get done, press play and we'll go over the results. Okay, we're back. Let's look at number 1. It states pressure decreases as altitude increases. And I think what we're talking about is air pressure here. So air pressure decreases as altitude increases. Adam goes on a hiking trip to the top of a mountain and comes back. So what that would mean is when he is at the bottom of the mountain, the pressure would be more. And as he hikes up in altitude and he gets higher and higher in the mountains, the air pressure would start to decrease. So we need to figure out which one of these scenarios fits that explanation better. So we have time and we have pressure. Okay, so this really, neither of these are dealing with altitude, it's just pressure. So Adam goes on a hiking trip to the top of the mountain and comes back. So that's all it says. He goes to the top and then comes back. So here in example A, the air pressure is high, so that would mean that he would be at a lower elevation and time is 0. Time has not started yet. But as time starts, he starts to hike up the mountain, and the air pressure is dropping the higher he hikes as time is going on. And then what this states is that he, gets to a point and he stops, and the air pressure at this point is just, it's consistent. Okay? And I don't know if this would not fit the situation, because this part is true. The air pressure is high as he hikes and he gains altitude. It would drop, but then he goes back down the mountain. So at the end of it, he should end with the air pressure being high again. So because of that, this would not be the choice. Let's go on to B. So we start at a high air pressure, which would make sense because he's starting at a lower altitude. As he hikes up the mountain, and time is going, the air pressure is dropping. I would think at this point, this is where the air pressure is very low. It's remaining the same. Time is going on. So I think that it's safe to say they're probably at the top of the mountain. And then it's time to go back down the mountain. And so the air pressure is really, really low. But as they go down, the air pressure increases until they get back down to the base of the mountain where the air pressure is high again. So this would be a scenario which would fit this explanation. Okay, let's go on to problem 2 and see how you did. This says a wildlife photographer travels 4 miles from his camp to take pictures of lions. Okay, we got a lot of information. So travels 4 miles from camp. Okay, so he travels 4 miles, and then what happens? They take pictures. So as they're taking pictures of lions, they're probably at a resting state, which means they're not moving in distance, but time is going on as they're taking pictures. Then what happens is they go 8 miles farther. So then they travel, and then what do? They get pictures of deer. So that means that they're probably going to stop again. So this just shows another change. Get pictures of deer, so they're stopping there. And then comes back to camp. So that shows a change. On his way back, he stops, take pictures of zebras as they pass. So as they're taking pictures, again, they would be stopping once again. So we aren't going to sketch a graph because we have 2 options. We're going to go ahead and figure out which graph best fits this scenario. So I'm going to kind of zoom in a little bit because these graphs, it's kind of hard to see them. So hopefully you can see them now. Okay, so we're going to sketch a graph to show the photographer's distance from the camp and then use the graph to find the total distance traveled by the photographer. Okay, so first let's just figure out which graph fits this scenario. So let's look at A. It says wildlife photographer travels 4 miles from his camp. So this is time and this is distance. So we are starting, time is 0 and we're at camp. So the distance from camp would be 0. This graph shows that we travel 4 miles. This graph shows that we travel 8 miles. So right off the bat, this one doesn't fit because we travel 4 miles and then we take pictures of lions. So this 4 miles here would match up with that 4 miles. The take pictures of lions, that would be we're not moving in distance, but time is going. So that would be this constant straight line. Then we go 8 miles further. So we're at 4 and we keep traveling up to 12. So that would be 8 miles. So that would go along with this, goes 8 miles further. So that would be this part goes 8 miles further. Be right here. That would be that. To get pictures of deer. Well, there we're not traveling any distance. Time is just going. So that would be, that would line up with this right here on top. This would be, they're taking pictures time. That's the time it's taking them, but they're not moving in distance. And then comes back to camp. So this would be them traveling back towards camp. But on the way, they stop again to get pictures of zebras. So this is them stopping to get pictures of zebras. And then after they do that, they're still going back to camp. So they go all the way back to camp right there. Okay, so this would, this problem, A, is a graph of this situation. Now what we need to do is we need to use the graph to figure out the distance traveled. So here, initially, they went 4 miles. They took pictures of lions, which means the distance didn't move. But then they went 8 miles to get pictures of deer, so this would be 8. They took pictures of the deer, so the distance didn't change, it was just time. And then they came back home, stopping for to take pictures of zebras. So this is at 12, and they stopped right here. It looks at the 8, so it looks like they traveled from 12 to 8, which would mean they went 4 miles there. And then from here, 8, this is at 8, and it went all the way back. So that would be to 0, which would be 8. So if we add up all these numbers, 4, 8, 4, and 8, we end up with, you know, that's 12 plus 4 is 16. 16 plus 8 would be 24. So that means there was a total distance traveled was 24 miles. Okay? Total distance traveled was 24 miles. So yeah, if you got that right, great job, and we will see you next time.